A biologist is interested in comparing the size of blue crabs in two river basins, Cooper and Stono River. Based on the health of the rivers, she believes the crabs in the Stono will have a higher average weight. She samples 32 crabs from the Stono River, and this sample has a mean of 800 grams with a standard deviation of 225 grams. She takes a random sample of 35 crabs from the Cooper River and finds the crabs have a mean weight of 700 grams with a standard deviation of 175 grams. Is there persuasive evidence at the zero point zero 0.01 significance level in support of the biologist's belief? Wow, there's a lot to take in with this question. The things that stick out to me as I read over the question is basically this idea that the biologist had, and that's that there would be a higher average weight for the Stono River basin. So I see that word average. And then as I look here in the text, I see that I do have indeed, I have the Stono River information. Here, I'll just underline it in red. And then also, I was given the Cooper River Basin also. So I have two samples to prop up and to use to test if there's a difference in these two river basins. So I see the word mean, average. I have quantitative values. They've measured these crabs' weights. So we're going to be testing two means here. A hypothesis test of two means. So just kind of game planning here. All right, two means. I do not know our population standard deviations. And I'm going to assume that the population standard deviations are not equal. So I don't have them, not making any assumptions about this. So that's going to give me a little bit more information. I'm going to end up using the T distribution to test this out, but we'll talk more about that when we get to the software. So on this next page, I'm going to try to summarize what I found on the prior page. So this column is going to be for the Stono River, and we had a mean of 800 for those crabs. Standard deviation of 225, and the sample size was 32 crabs. Now for the Cooper River, just to stay with the coloring I was using earlier, we had a mean of 700 grams, standard deviation 175, and a sample size of 35. So I'm going to keep that just organized. I like to get it out of the paragraph so that it's easy for me to access it when I need it. So without further ado, we need to write down our hypothesis statements. So this is two means. I'm going to put two means in each of my hypothesis statements here. Okay. Now we just have to figure out which ones are which. Now, I really do like using subscripts that make sense to me. So I'll use S for Stono rather than 1 and 2, which that works well, you know. And then I'll use a subscript of C for the Cooper. So just in the same order that I had written them, I wrote the Stono down first, then the Cooper. We're going to figure out how to relate these two. Now, in our null hypothesis, we always have equals to here. And the biologist's belief and hunch was that they would be larger or higher average weight in the Stono River Basin. So I'm going to put the inequality as a greater than. And so I think we have everything we need. Also, let's note that the significance level was 0.01, and I believe that's everything we had from the prior slide. So let's head to Rguroo. All right, so we're here. We're not accessing data or anything. We've got everything summarized within that problem we read. So we're going to go to the analytics pane, drop down menu of mean inference, and then we're going to go to 1 and 2 population here. See, it's opened up here. And what I need to do, I don't have data, so I'm not going to mess with anything at the top. I'm going to go down to what's called summary. So our population 1, where our first one we wrote down on the left side was the Stono. So I'm just going to put Stono there for short. And then put in what we know about the Stono River. 800, 225, and the 32 crabs. Come over here. This is going to be the Cooper. The sample mean there was 700. And the sample standard deviation was 175. And there were 35 crabs. Okay. So I have all of that. So it needs to know the summarized evidence we have here. That's the tab summary. Now I'm going to go all the way over to population 1-2 because I want to be able to do a hypothesis test using both groups. So we're going to also, you can see it has identified Stono as group 1, Cooper as group 2. I'm going to go to hypothesis test here, this tab. Throw in my significance level. And one thing I do want to mention, this looks a little awkward. Let's go back to the slides. Now, what's happening here is that oftentimes they'll write the hypothesis statements with both means on the left side of the inequality. So if I were to subtract the mean for Cooper from both sides, another way to write the second hypothesis statement, our alternative hypothesis statement, is like this. Now, again, this is just an alternate way to write it. You do not have to write it that way, but this is the way a lot of software packages recognize the hypothesis statements. So here we are. So that's what it means here. Alternative hypothesis, mu1 minus mu2 is greater than 0. So that's how we communicate it. And I'm going to choose the t statistic. And we have unequal variances or unequal standard deviations. That's great. And then we click preview. So it gives us back that what we entered in that summary portion. So double check your data entry, make sure you didn't mistype something. Then we get to the test statistic here. We got a test statistic of 2.39 and a p-value of 0.024. So we'll take a look here. If we want to look at some graphs, it's down here. But I want to take these two pieces of information over and do a little decision. All right, so my test statistic t-stat was equal to 2.39. My p-value is 0.0242. And I'm going to put that next to my alpha here that was declared to be 0.01. And now I have to figure out, what my decision is going to be. I put these side by side. You've seen me do this in other videos. And if I look at p-value and alpha and I just decide which one is a bigger quantity, well, the p-value is. So that means it's greater than alpha, which means we're going to fail to reject our null hypothesis. I'm going to fail to reject it. So that means I'm going to keep it. I cannot reject it. Our data is not persuasive enough. So the alternative kind of is out of consideration now. And as I walk away from this study, I am leaving with the notion that the mean weight in the Stono Basin is equal to the mean weight in the Cooper Basin. And so if I go and write an overall statement, have it pre-prepared now, there is not persuasive evidence to support the biologist's belief that the mean weight of crabs at the Stono Basin River are significantly higher than the mean weight of crabs at the Cooper River Basin. We saw a subtle difference between the two, but it wasn't persuasive enough to say that there's a significant that the Stono is significantly higher mean than those in the Cooper River Basin. Hope this was helpful.